Welcome to TypeScript FM, the friendly podcast for TypeScript developers where we bring you news, updates, and interviews from the community with plenty of tomfoolery sprinkled in. I'm your host, Kamran and Erik, and I'm joined by my co-host and best bud, Erik Onerheim. Together, we're the two TypeScript fools. Welcome to the show. How's it going for you, Erik? How was your weekend?
It was okay. We had a little bit of sleepless nights. My daughter's pushing out molars right now, so that's been a blast for everyone involved. And now this week, she's been promoted to the toddler room, which she did not like. She was not a fan of this morning.
Oh, really?
Yeah, she was very sad.
Does she miss her friends then?
I think she misses her teachers. So
Okay.
I walked by one of her teachers and she's like, wait, I'm not going in there. And that's when it started.
Yeah, that's too bad. Yeah, that consistency, that's hard.
Yeah.
Do your teachers ever go in between classrooms?
It seems like they do. It seems like it's pretty fluid, but yeah.
Yeah.
Very sad. And I think she'll be fine. A lot of the way that they do it is the kids grow up in the same kind of cohort. So she's going to see kids that she saw before that kind of aged into the toddler room before her.
Yeah, our kids still keep in touch with kids from daycare, the same cohort they were in. And similarly, like the teachers in our daycare go in between rooms sometimes, so they still get to see each other. That's awesome. Hey, did you watch the Super Bowl on Sunday?
I did not watch the Super Bowl. I slept instead. I was very tired yesterday.
That's probably a good idea. Did you have any proclivities towards one team or another?
I have no idea who was playing.
Okay.
I just know that maybe it was like the Taylor Swift's boyfriend versus the other team. I think that's all I know. And I heard from a few people that it was a surprising game. Yeah. And I actually don't know who won. Like, legitimately, right now, we're recording the day after the Super Bowl. The Super Bowl, excuse me. And I legitimately don't know who won.
Well, it was Chiefs versus Eagles, and the Eagles won by a long shot. They owned them. It was like 40-20 or something like that. So yeah, I didn't have any feelings about a certain team, but we have friends who are from Philly, so they were very into it and they're super happy.
I imagine so.
Yeah.
I hope Philadelphia is also doing okay after the Super Bowl.
Yeah. Yes. Actually, so the Super Bowl was held in New Orleans.
Yeah, that doesn't stop Philadelphia from getting
rowdy.
True.
That's true. Probably even more so than that, like where it was actually held. So that's funny. So last week I've been working, like I mentioned before, I've been working on my personal agents course, AI agents, and it's pretty much done. Just addressed some feedback today. And I have to say that I'm actually impressed with building some pretty straightforward AI agents. Now, I tried a bunch of different tools, and the one that I landed on to demo for non-technical people is Zapier agents. And Erik, you've used Zapier before.
Actually, I haven't.
Oh, okay. It's pretty popular with like business professionals because it's a low-code, no-code tool, and it has a visual builder so you can connect apps together. And I think it boasts probably one of the biggest ecosystems. It can connect over like 7,000 apps. It's not the most powerful kind. I've heard of make.com and I think one called Pipedream. I don't know, could be getting it wrong. Those ones I think are more popular with developer types because I think you can do some coding in those. This one, like Zapier, is pretty much all no code.
Is it like an if this then that kind of
It's
idea?
if this then that. Okay. Yep. So if you're familiar with if this then that, it's similar. So other than that, I mean, we had a good weekend. Our kids had their birthdays, so we celebrated their birthdays. One turned 8.
I saw the Pokeball cake. That was really cute.
Yep, my son is into Pokemon. They made a Pokeball cake. My wife and the kids did. And then my daughter shares the same birthday as my oldest. So she turned 3, he turned 8. And she wanted a lion cake, so they made that as well. And it's a little bit funny because this week our oven died. It doesn't work. It won't ignite. So that's
a problem.
Yeah, it's on, like it has electricity, it just won't ignite. So the appliance appointment's not till this week on Friday. So they had to go to our buddy's house to actually bake the cakes.
Oh, wow.
Sweet. There's quite a bit to cover for the week of February 3rd. There was a couple PSAs I think that we want to get out of the way just so people are aware. you might have been affected by an issue with Node.js. They have a downstream dependency on a package called Corepack. And I don't want to try to explain it too much because I'm sure I'm going to get it wrong. But the end result is that your CI/CD pipelines could have been broken by it. And then if you tried to install new versions of PnPM or NPM, it was probably failing. And it was failing because, I guess, some keys got rotated with Corepack when they were publishing. And so some old packages were signed with the older keys, which expired that week. So that's why it failed. So PSA, if you are affected, it should, by the time you hear this, it's backported and should be also in the new releases of Node.js because it comes bundled with it. So you have to install it. There is a workaround where you can manually update Corepack, but that doesn't work in CI. So in order to fix your CI/CD pipelines, you do have to update to the latest patch versions of Node.js.
And props, they moved pretty quick on fixing that.
Yeah, it was really quick. Yep. So this is going to be old news by the time you hear this. That's just good to know. The other thing that's also good to know has been patched is some vulnerabilities in Vitest and Vite. Since we just came off an episode talking about Vite, just make sure that you have the latest versions of those. One was like a remote code execution vulnerability in Vitest, and it would only affect you if you were using the Vitest UI, which I don't, but if you do, it enables like an API option, and I guess that was vulnerable to remote code execution. But I think the more serious one was in Vite. If you use the dev server at all, it affected you. Those fixes have been backported to the major versions. Just update to the patches and you should be good.
Yeah, and they were pretty severe. They were like, the first one was a 9.7, which is like basically a low complexity attack can own you. It's not good. So definitely make sure that you're running the latest.
Yep. And that's super important if you're working in a company. If you're working personally, it'll still affect you, but for sure you want to update if you're working on a team.
All right, moving on to community highlights. I've got 2 right in a row from Duality because he's cranking out bangers. The first one I wanted to talk about is now that we're looking at erasable syntax, we're looking for replacements for enums. And Duality has a really good blog post. I'm not going to dig too deep into it, but he talks about the different ways to get that same type of feature that you might want out of enums. And goes really deep into the trade-offs, like very deep. So I do recommend reading his post. That'll be in the show notes. And suffice it to say, all of the different ways of doing enums have a trade-off of one thing or another. And depending on what you're doing is going to be how you make a decision. For example, like one thing that I do a lot of, and I talk about a lot, is doing just a constant with string keys. Now, those have some trade-offs in terms of speed because string comparisons are slow, but that might not matter for you if you're not doing comparisons in a hot loop. For example, symbols and numbers are faster, but they're also more difficult to debug. Trade-offs. But I do recommend taking a look at his post. He dives really deep into various enum replacements, their trade-offs, and some of the things that you might want out of an enum, type check exhaustiveness, like in a switch, and which approaches support that and which don't. And there's a lot of really cool approaches in his blog post. So I definitely recommend checking that out. And next up, Duality also has a great tutorial doing TypeScript and ESM publishing. And it's a detailed article. I have been looking at this. I've needed this like a year ago. So I do recommend checking this out. He's got all the latest and greatest compiler flags that you want to have on if you're doing this. And in fact, I'm probably going to go back through my TS configs and make these changes.
That's good because for Excalibur, do we publish a ESM package?
We do. We do publish an ESM package. We use Webpack's still alpha feature for generating the ESM bundle. It comes with some downsides, but it is compliant and it does wind up reducing the bundle size because the ESM can be understood by other bundlers and it can like really deeply shake an ESM bundle. Mm-hmm. So that's actually pretty cool.
That is neat. Awesome. There was an interesting hot take article posted by Anthony Fu, and he wrote a blog post this past week called Move On to ESM Only. And so he sort of is making the case as maintainers and as the community, we should be moving on to just using ESM with Node.js. And I think just based on the thread and people's reactions to it, I think there's pretty much unanimous support for this because we're tired of having to deal with both CommonJS and ESM worlds together. I think there was a little bit of criticism, rightfully so, I think, for what about compatibility with legacy tools, because this would break some older Webpack builds and stuff like that. So I think it's a good point. There's not a great 100% definitely going to work strategy for moving to ESM, at least with Node. I do think probably the most promising path is that as a maintainer, you might say, once experimental ESM support is gone from Node LTS, like the end of life, then we're going to just support ESM, because then people who are on at least supported versions of LTS Node should be able to consume my ESM-only package. And then that way, it's sort of like just a natural progression of like, okay, if you're using a Node version that's end of life, like you should expect that things are going to break, right? So
yeah. And I think the thing that made ESM a lot harder to support than like using Common was the one-way nature of it. We talk about this at my work a lot, is one-way decisions versus two-way decisions. And one reason you might have been like, I'll just stick to Common is because it works in both places, versus ESM only works in ESM, right? It's Common's a two-way door and ESM is a one-way door. Now, there are advantages to ESM, but I think the way that one of the knocks is that it basically said, oh, all of the code that's on the internet right now won't work. So it's maybe that's the knock I would give, is like, I think that we're past, the ship has sailed. So it's not worth belaboring, but I think that was maybe the knock on ESM. And that's why it's taken so long, is it's just very challenging. And now there's a lot of like things like GD and other tools for working with both at the same time. And then a lot of runtimes are now also supporting both at the same time.
Yeah, I think there are folks that will say, from a purist point of view, like CommonJS is not part of the ES standard, right? So we should get rid of it. And ESM is the future, and we should just all align around it. But then pragmatically, you also have to realize that Node.js is the biggest ecosystem by far from any of these other runtimes. It's sort of like the least common denominator type of deal, where like once Node evolves to the point where you can safely just use ESM and it works, then we can start talking about migrating everything to ESM. But until that time, like as a library maintainer, depending on who's using your library, there's still probably going to be a concern about legacy support and backwards compatibility. So next up, we've got a really cool blog post from George Hadar where he dives a bit deeper under the hood into HTTP2 protocol support in these different runtimes. So he tested Node, Bun, and Deno. Deno has full support. I don't think that's a huge surprise. So what's really interesting, this is something I didn't realize, is that at least right now, Bun does not support HTTP2 out of the box.
Oh, interesting.
Yeah. George says that sadly, Bun does not appear to support HTTP2 with its fetch implementation at this time. And he actually tried testing it with, I don't know how you pronounce this package, Undici, UNDICI, but apparently that is a fetch package for Node that should work. But it doesn't work with Bun. So there is an open issue. So hopefully this will just be addressed in the future. But anyway, I thought that was interesting. And so he was trying to build a TypeScript SDK generator, and he was running into this across
interesting.
Yeah. If you do monorepo stuff, you might have heard of the tool NX, and I've not used it, but I've heard good things about it. And they just wrote some blog posts on using TypeScript with NX monorepos. So if you already doing TypeScript and you have a monorepo, and you might want to check out NX. So we'll link to that in the show notes. The other thing that came across Blue Sky I saw was pretty cool, is like a massive bookmarkable page and PDF from Zero to Mastery called the TypeScript Cheat Sheet. And this is something that they developed as part of their TypeScript bootcamp that they made available to everybody. So there's a link to that in the show notes. You can get the PDF version, or you can just view the page and bookmark it. But it's like everything in TypeScript, like stuff that you might want to do day to day. So that's pretty sweet. Joshua Goldberg has his Learning TypeScript book, and he had a thread about using TypeScript comment directives. I don't know about you, Erik, but I use these sometimes, like the tsignore, especially tsignore. And also there's a few other ones I think that I wasn't even aware of.
Yeah, tsignore gets broken out a lot when I need to do something really funky. That is, trust me, this is something really funky that I need to do to interoperate with. Like one good example is like the way that the Excalibur works with the DevTool plugin. It hoists a global that hangs out on the global this, and you could type it properly, but I didn't. And tsignore is useful for that kind of stuff.
Yeah, so he also shows like tsexpectErr, which I think I've maybe used a couple times, where it's like, yes, it's expected that this is going to throw an error.
And that's actually super useful if you are doing like you're testing your types. If you're looking at doing like unit testing of your types to make sure that your types are working the way you expect. So if something should error, you can say, this actually should error in my test. And you can have your test files actually do that. And I think I have a couple where I actually do that.
That's cool. We need like another episode on testing TypeScript types, that's pretty cool.
One really cool thing that also showed up on Blue Sky is, I don't know how to pronounce their name, but it's username EASRNG. She built a JSR loader for the browser. So you can just import JSR packages like you were in Deno in the browser. And it's super slick. It works really well. I think it's more of an experiment than a production ready software, but it's relatively low code to go and look at the source. It's like less than 300 lines of code to do the JSR import in the browser to ship this. And I thought it was really cool.
Yep. And so just to be clear, it's not like an announcement of a new library. She just posted it and said, hey, chat, I built this thing. Isn't it cool? And it is pretty cool.
It is very cool. So yeah, definitely check it out. She's got some cool stuff on her website too. So you should definitely go check that out.
TypeScript FM is sponsored by Excalibur.js, the friendly TypeScript game engine for the web. Like many of you, I got into computers because I loved video games and dreamed of making one, but game development always felt a bit intimidating. Instead, I built a career in web development, though that dream of making games never really went away. Then I met Erik, who showed me I could use my HTML, CSS, and JavaScript skills to create games with just a bit of game design knowledge and the right engine. Excalibur.js makes game development approachable, offering everything you need to build 2D web games. Arcade physics, sprites, animations, input support, and integrations with tools like Tiled and Sprite. It's beginner-friendly, yet flexible enough to grow with you. Our team has published 10 games using Excalibur, all written in TypeScript. If you're a web developer looking to dip your toes into game dev or sharpen your TypeScript skills, give Excalibur.js a try at excalibur.js.com. Click the big tutorial button to start building your first game, Excalibur, a Flappy Bird clone. After that, join our friendly Discord community of web developers who love to help each other and share game dev tips.
Sweet. All right. We're going to dive into the big topic today. Now, in the past few episodes, we have thrown out probably maybe not a dozen, but we've definitely thrown out a lot of tools that maybe not everybody is going to be familiar with. So we've talked about tools like SWC, TSC, Bun, Deno, esbuild, all sorts of stuff. We've talked about Rust-based tools. We've talked about Go and all this kind of stuff in the TypeScript ecosystem. And so I think in this episode, we just sort of want to wrangle this all together and make it a little bit more clear. If you are coming into the TypeScript ecosystem, what are the tools that you need to know about and care about? And how do you build your tool chain? And what's the difference between all these different tools? What are they good for? What do they fit? So that's why we're going to talk about compilers, transpilers, runtimes, interpreters, engines, all that kind of stuff. And I think we just want to start with a simple question, which is, what is a compiler and what's a transpiler? Erik, explain.
Yeah. So transpilers is the word transpiler is a recent term, and it's maybe a misnomer, or they're basically the same. Compilers and transpilers are basically the same. They're doing the same thing. They're translating one language into another. Now, you could argue that their usage in practice is maybe different. You could argue semantics, where a compiler might be more on the spectrum of you're translating a language into a runnable artifact in a lower level language, for example. So giving like the C example where it translates into machine code. And then a transpiler might be on the spectrum of it's translating laterally from a high level language to another equally expressive high level language. So you might be like talking about TypeScript to JavaScript, for example, might be a transpiler. Now, none of the TypeScript itself calls itself a compiler. So I think the transpiler and compiler are used very interchangeably nowadays.
Yeah.
And I don't think the distinction is really important. You're converting code from one form into another.
Yes.
At the end of the day. But I certainly use them interchangeably. Usually I think that the word transpiler is thrown around in the web space more than compiler.
Okay. So they're basically the same thing. So when someone says that, you can just, in your mind, you can just say it's a code translator. It's translating code from one format to another. Could be the same language, could be a different language. Why do we need a compiler for TypeScript?
So this is a great question. And hopefully one day we won't, but that's just a personal opinion. But TypeScript isn't a language that the browser can run.
Okay. At least today.
There's an ECMAScript proposal called Types as Comments. I think it might have a different name now, but effectively it's type stripping in the browser as part of the ECMA standard. And it would be in line with this erasable types idea. But TypeScript doesn't, in the current world order, run in the browser, at least at the time of this recording. But JavaScript does. And JavaScript is the lingua franca of the web. If it's in JavaScript, you can run it. And one nice thing now is that the web has won. JavaScript runs everywhere, and whether it should or not. And that's what the TypeScript compiler is doing, is it's moving this TypeScript into JavaScript.
Okay. And so specifically with the TypeScript compiler, that's TSC, that is built by Microsoft.
Yeah.
And it's something called a bootstrapped compiler.
It is. So this is actually like it's a fun term, and it stands for pulled up by your bootstraps. Mm-hmm. And when you hear the term bootstrap compiler, it means it's a compiler written in the language that it compiles. So TypeScript is written itself in TypeScript. So that's why they call it a bootstrapping compiler. And it's like the test your metal of a compiler is if your compiler can compile the language it compiles, it's doing pretty good. It's at least expressive enough to compile your own language.
Okay. Okay. It's very magical to me. So I've never taken like a computer science class on like how to build compilers. I think you did once, long time ago.
Yeah. And I didn't do well. Yeah. It's pretty magical. It twists your brain a little bit. And there's techniques for making that idea, that contradictory like chicken or egg problem actually work. And it usually involves like having an interpreter for your language, run your compiler through, and then it spits out a compiler for your language that's now optimized that can build your language. So that's usually a bootstrapping process. Is there's a simple interpreter for your language that will compile your compiler, and then as an artifact produce your compiler.
Oh boy.
That's generally the technique.
It's compilers all the way down.
It is compilers all the way down.
So you introduced another term there, just to go back quick. Interpreter. What does an interpreter do exactly?
Yeah, this is another great question. And an interpreter, roughly speaking, and some of the lines start to blur when you start talking about things like C# or Java. But roughly speaking, an interpreter interprets instructions as they're read. So it's a much simpler approach where like it receives a token, it receives an instruction, and then it runs it right away on the machine.
Okay.
So like you write the print command, it runs the print right then. And it's like reading line by line and executing line by line.
Okay.
Versus like a compiler, which might just hoover up your entire program, produce a tree, and then spit out a binary, which is a different modus of operation.
Gotcha. I'm thinking about this on the fly, but if I'm reading a book and I'm reading it word by word, that's like what an interpreter does. Whereas a compiler would read the whole book and then, just as a metaphor, would summarize it. Like it wouldn't tell me everything line by line. Like it converts it to some abstraction, and then it converts that to something else.
You know what? One way to do it is it's if you were reading a book to your kid versus that's an interpreter. You're reading a book to your kid versus handing your kid a book and asking for a book report.
Gotcha. No, that's a great way to explain it. Okay, cool. So that makes sense to me now. And so what is an engine? Because we've talked about V8, and I think it's well named because if we are talking about maybe like a car metaphor, V8 is the engine, and then the car itself is what we call the runtime, which is where your app runs in production. Like, where are you putting it? Is it in the browser? Is it on the desktop? Is it running under Node.js? Is it running under Deno? That is the runtime. But each of these runtimes are powered by JavaScript engines. So what exactly is an engine?
And I think engine and maybe interpreter are thrown around interchangeably, at least I do. And I think the nuance I would put on it is an engine is more, I guess I'm just going to say complicated, because V8 includes an interpreter and a optimizing compiler. So it's a lot of stuff to make your JavaScript run fast. Especially V8 and SpiderMonkey and JavaScript Core are more than just interpreters in order to make JavaScript fast, because JavaScript is unfortunately a very tricky language to run because of its loosey-goosey nature, hence why we like TypeScript a little bit, at least on this podcast. In this house, we like TypeScript. Engines, like browser engines like V8, do a lot of tricks in order to make JavaScript fast.
Okay, so you just mentioned 3 engines, but I want to make sure that we take a pause there. So V8 is probably the engine most people know about. That powers Chromium, it powers Node.js, and it powers Deno.
That's right.
There's another engine called SpiderMonkey that powers Firefox.
Yep. And that I think it has evolved from the original one that Brendan Eich wrote.
Okay.
So its ancestry is the first JavaScript engine.
Okay. And then there's JavaScript Core, which powers Safari/WebKit.
That's right. And Bun.
And Bun. Oh, yeah, that's right. Yep. Yeah. So these engines power these runtimes. There are other engines for different platforms too, to make it even more confusing for you, dear audience. Me and Erik are .NET developers, or historically .NET developers. And I remember needing to run JavaScript using some other engines, like there's one called JScript.NET. There's one called Gent, which might be a more modern one. And then if you're a React Native developer, there's one called Hermes, which lets you run React Native on native mobile apps and stuff.
Yeah. And one thing about Hermes that's interesting is it's just enough JavaScript to run React Native.
Okay.
So it's like almost JavaScript. It's like a subset of JavaScript for React Native.
Okay. So just to recap real quick, we've got compilers, transpilers, basically the same thing. We've got runtimes that can contain interpreters that are all powered by engines. So engines have compilers and interpreters in them, but our code itself also gets compiled. So there's multiple levels of compilers happening. But I think the things that we want to focus on as TypeScript developers are the dev tools in our tool chain to build our apps. So we're going to focus on those compilers. We've got TSC, which is the official TypeScript compiler. And then we've got, if you have been around long enough, we've got Babel, which is a transpiler for JavaScript. And you've probably used that even without thinking about it. But if you have written any kind of modern JavaScript with ES imports and you have to target older browsers, historically, we've always used Babel to take that code and transpile it to a version of JavaScript that runs in the browser that's compatible. I guess you could think of Babel as the OG transpiler.
Yeah, and that one's interesting because it's JavaScript to JavaScript.
Yeah.
Like the future JavaScript to current JavaScript or older JavaScript.
And we have no evidence for this, but I feel like the word transpiler got introduced when Babel came onto the scene.
I would believe you. Because it's going JavaScript to JavaScript. I would believe that.
Right.
I don't know if that's true.
I don't know if it's true either, but I feel like that's the first time I heard that term. Okay, so that brings us to SWC, which is Speedy Web Compiler. It's written in Rust. And I think the cool thing there is that it's supposed to be a drop-in replacement for Babel. So it can take JavaScript or TypeScript, and it can transpile that the same way that Babel does. The biggest benefit there is that it's way faster because it's written in Rust. And I think this is a theme that we're going to see now for some of the other tools that we talk about, is that we've got this sort of like old school tools, like some of the original tools that are written in JavaScript that the community has felt they're a bit slow for building these really big apps. And so someone goes and creates a Rust-based version of it, and now that's the new tool that replaces it. So I think for TypeScript developers and SWC, it is unlikely that you would use it directly, but you might. And if you do, there are some things to be aware of if you are using it instead of TSC. One of the big things is that there's no type declarations. So if you are creating a library and you need to create a types package for it, you're still going to need to use TSC and maybe one other tool that we'll talk about next. But SWC doesn't create type declarations for you. It only does transpilation. There's no type checking. So that's another thing that TSC does. It doesn't just compile your code, it also type checks it. So that is the source of truth for your TypeScript app, making sure that the types are right. A lot of these other tools don't do type checking. In fact, I don't think any of them do. And some of them might have plans to do it in the future, but at least for right now, TSC is the only tool that can actually do type checking. And now, in order to build your app with SWC and some of these other tools, you have to have your code in a specific way. Your TSConfig needs to be set up in a specific way. There's a flag, pretty much all of them share, called verbatimModuleSyntax. That's in your TSConfig. It was recently introduced in 5.0. And it's because there used to be 3 other flags that you'd have to mess with in order to get these tools to work with your TypeScript app. Isolated modules is one. Import values not used as values is another config option. And then preserve value imports is another config option. So verbatimModuleSyntax is just a single flag, and it basically flips all of these to true.
Yeah. One way to think about it is if you read it, verbatimModuleSyntax, it's actually super simple. It doesn't do like anything to your module syntax.
Yeah.
So, like the way you would write ESM imports is the way that the TypeScript compiler, it won't touch them, is the way to think about it. And that's why it's verbatim. Because in the past, we didn't have all of the fancy pants ESM support everywhere. So TypeScript would either do optimizations or transform your imports into requires, for example, if you were doing like common. But verbatimModuleSyntax says, do not touch my imports, leave them as is. That's one way to think about it.
Yes. That brings us onto another tool that we've talked about that's similar, but still different, esbuild. Do you want to talk a little bit about that?
Yeah. Now, esbuild is a similar idea. It's on its page, it says the extremely fast bundler for the web, which I think is accurate. And in our last show, we talked about how Vite uses it for their dev mode precisely for that reason. And it's extremely fast. Their benchmark is it's like the fastest thing since sliced bread. And same deal as SWC, does type stripping, no type checking, no type declarations, very similar restrictions to SWC. And I think partially the only difference really is that it's written in Go and the configuration is going to be different. Some of the things to think about with esbuild is it's working like on a file by file basis. So it can parallelize is partially why it's so fast. So one thing you might want to think about is building your TypeScript with isolated modules. And what does that mean? That just means that all of the types can be for a file can be inferred by that file. That way it doesn't need to go and crawl your code base for different types.
Yep. When actually that's pretty much the exact same as SWC, because like I said, the verbatimModuleSyntax is the new flag. So you don't even have to set isolated modules to true if you're using the verbatimModuleSyntax. But if you're on TypeScript 4 or below, you will have to set that additional TSConfig flag.
And in fact, isolated modules is faster for TSC too, for that same reason. It doesn't have to go and troll your base for types.
Nice. Okay. That doesn't quite explain why Vite is using both of them together when on the surface it feels like they're the same. But I think the reason is because esbuild has such a fast incremental build where it can just do it way faster.
Yeah. And in the last show, we touched on the reason why they did the split. And it's mostly because Rollup, which is what they use for their production bundles, has like a diverse plugin ecosystem and a lot of flexibility for production bundles. but it's written in JavaScript and it's much slower than esbuild. So that's the trade-off. Is esbuild is great for dev mode, runs really fast, and they use rollup for their production builds. They also do use SWC, but they use it for producing they use it both in their dev mode and in their prod mode, but they use it for producing their abstract syntax tree for the purposes of understanding the code for bundling purposes.
Okay, I get it now. So so they're using SWC because it can spit out the abstract syntax tree a lot faster.
Yeah.
And then esbuild is used to actually do the building. Okay, so that makes a little bit more sense. But what's funny is that both of these tools, at least in the context of Vite, are being replaced by this new thing called OXC. OXC.
Yeah. And this is being built by Void Zero. So this is the company that Evan Yu started, and their purpose is to provide like world-class developer tooling, and they're working on Vite and they're working on Rolldown. And this is the core component inside of Rolldown that is going to do the things that esbuild and SWC did. And they have some pretty impressive numbers on their page. Like it's 4x faster than SWC, for example. And they're both built in Rust. So it's not like this is Rust and this is Rust. They're both Rust. And then compared to Babel, OXC is 40x faster at transforming source. So it's some pretty impressive stuff. And, if you needed more impressiveness, it works with the infamous checker.ts file, which is the TypeScript compiler file that implements the type checking, which is like extreme. It's known for crashing compilers and because it's so large. So it works with checker.ts, which is pretty amazing.
So it's like a benchmark, like it can actually process that file.
Yeah, that file is a truly Gigundous TypeScript file with high degree of complexity, and it can do it. And I think Rob Palmer has a tweet to that effect. The other thing that's interesting with Oxide is they are also playing with doing declaration support. So they can emit declaration files with Oxide. And this is something that no other tools are really touching as far as I'm aware. And this would be great, especially if you're building libraries and things that you want other people's to consume. And there's an announcement we'll have in the show notes written by Rob Palmer on the TypeScript 5.5 beta that talks about it. But it relies on this idea of isolated declarations, which we talked about, where you don't need to troll the whole project. So it makes it possible. It's a smaller problem space than doing it like a type check is emitting these types.
So this is pretty huge. So just stepping back for a second, when I was working at Target on the web platform team, we were dealing with over 80 packages in our monorepo, and some of them are libraries that we built to depend on, and then others were like runtime packages to actually run the server and stuff like that. So when I looked at this, switching away from TSC because it was slow, I was able to speed it up twice the speed, but it was still taking 2 minutes or something like that. And so I looked at SWC, and sure enough, it was super, super fast. I don't even remember what the benchmarks were, but it compiled it in less than 30 seconds, all 80 packages. The problem is that it did not output the type declarations. We couldn't use it because we needed those type declarations in order to reference those packages and use them. So if we were going to use TSC anyway to generate those type declarations, we might as well just use TSC only, right? Rather than introducing a new tool. But now with OXC, the promise is that you could do that. You could just use OXC to not only transpile the code and build it, but also generate the type declarations. So you could just use one tool. So that's actually huge. So that'll be really exciting to see if they can manage that, because I think right now it's obviously still in development. So I think we'll be watching that really closely to see what they do, but that is pretty cool.
And the caveat is you do need to change how you write your code to have explicit types on everything for this to work, because it's not going to do the type check. So it's not going to go and do the inference to figure out what your types are. So you do need to explicitly type everything. But that does have advantages, knock-on advantages, because if you do explicitly type things, it does make the type check faster. So it does more than just give you declaration files. It does make TSC faster because it knows that what the type is just patently by looking at the snippet of code.
So it's kind of going to be a trade-off, right? Because the implicit typing is really nice as like a developer experience. But if I'm building a library, maybe I'm going to choose to do the explicit typing so that I can use these faster tools. Or you could adopt it on a case-by-case basis, which is probably what you would really do, which is if you have a package that's taking forever to build, or you have a set of packages that's taking forever to build, maybe you decide to use explicit typing so that you can take advantage of these new tools just to speed it up. Or maybe you do something just in CI or CD, or you do something just in dev, and then you use the slower tool. You use TSC and CI and CD to make sure that everything is hunky-dory.
That's right.
Okay. So we've covered SWC, we've covered esbuild, we've covered Oxy, the new one. There is also Deno compile, which we've talked a little bit about before, but it's quite different than either of these tools.
Yeah, and I think that the novelty here is that it, as far as these other ones are producing JavaScript, Deno can also produce a binary for you. And in this binary, you can roll in native code. Like, that isn't JavaScript. So you can roll in WASM, you can roll in C code, Rust code into using the foreign function interface, which you might want for one reason or another. Their stated use case at the beginning is like, oh, you can build command line tools really fast, and you can distribute those command line tools really fast because it'll cross compile for you on any machine. So you can be on a Windows machine and build a Mac tool, which is pretty cool. And now you can also be like, oh, I want to make a game. So I'm going to go use the foreign function interface to call native code and maybe draw something to the screen. That's maybe one reason to look at Deno, is like this novelty of being able to call native code and produce a binary and distribute it very easily.
Yep. Okay. So that's a good transition into, like, Deno is not a compiler. It is a runtime. And what are the different runtimes that we need to deal with as TypeScript developers and JavaScript developers?
Yeah. Historically, there were the big two, right? There was the browser with capital B browser. And you might say, okay, every browser that exists and all the quirks therein. But the browser is a runtime in that it has a JavaScript engine for parsing and running JavaScript, but it also has a bunch of other things that it does. Like, it renders a DOM, it does timers and set interval. It does all the other things that a browser might do. It might play audio. It might do all these other things that interact with your operating system. So that's JavaScript. So you can think of a runtime as like JavaScript plus other goo. So like Node is JavaScript plus an event loop, libuv, and a bunch of other server goo that you might want to do, like with talking to the network. And then Deno, very similar, it's TypeScript asterisk type stripping plus their own server-side goo with Node support. And then Bun is a similar idea, but using a different JavaScript engine and writing a bunch of other stuff in native languages like Zig to try and boost the performance of their JavaScript. So It's JavaScript, TypeScript plus runtime goo.
Yes. And so the differences between Deno and Bun, they are pretty different in what their goals are, right? So Bun, their goal is to be a drop-in replacement for Node. So things just work. Whereas with Deno, you have to opt into their opinionated way of doing TypeScript first development. But for example, I was just going through some of Bun's documentation and trying to understand what the major differences are. Before on the podcast, we've talked about how, from a developer experience perspective, it was nice to be able to import stuff without extensions. Turns out that Bun just supports that. So it just works, which is pretty cool. You don't have to have any additional flags. So it simplifies that module resolution. It has built-in TSX support, so you don't need to do any extra configuration to import TSX files. It just works. The other thing that's cool is they're claiming that they're about two times faster for the HTTP server than even Deno is. However, that's just based on their homepage. Things could update in that realm. So you can take it with a grain of salt. But the other cool thing that they have is like a built-in WebSocket server. So I remember having to do this with Node.js using like Socket.io. You'd have to set up all this boilerplate just to get WebSockets to work. With Bun, it just has a built-in WebSocket server. So that'd be cool if you're doing a lot of multiplayer stuff, whether that's a multiplayer game or you're creating like a collaborative app that requires multiplayer. So that's pretty neat. So those are like the three big ones, I would say, right? The three major ones, Node.js, Deno, Bun, and then obviously we've got the browser, the default one. But then we've got these smaller little runtimes that are gaining in adoption because of serverless JavaScript. So two of those, one is Worker D, which is Cloudflare's JavaScript and WASM runtime, and that powers Cloudflare pages and workers. And then we've got Vercel Edge to power Vercel functions to do other serverless stuff. Now, both of them, they're still different, where like Worker D supports a subset of the JavaScript runtime, and it doesn't quite have a lot of Node API compatibility. It does have some, and I'll link to a page that really dives into what the exact coverage of what APIs they support, because I'm sure, it's going to evolve over time. But they're focused on web standards. So they have fetch, they support web crypto and stuff like that. But it's still like a work in progress and a beta, and they have a really big kind of call out that's like, hey, we're still working on this. There's a lot of performance opportunities. We're nowhere near where we want to be for performance. Mm-hmm. So I think that's just something to keep in mind. And then with the Vercel Edge runtime, even though it's built on top of V8, it still supports a subset of the Node.js API. So there's still stuff that you need to worry about for what's compatible. Mm-hmm. And I think that is a theme with these other runtimes. The reason that we've seen this evolution of, okay, now Vite supports the environment API, and here's why we need to package this stuff in different ways, is because now our TypeScript apps are no longer just going to Node.js in the browser. They're going to be used in all these different runtime environments, and they all have different API services and different compatibilities, and it's like a total chaos. Basically.
It's the early browsers all over again. There's this term that's thrown around called isomorphic, which is fancy pants speak for the same code running everywhere. So writing isomorphic JavaScript or TypeScript is a real challenge if you want it to run everywhere. There's not a good solution. It's really hard.
Yeah. What is the community doing to try to tackle this chaos? There's something in the works called Winter TC, which is the Winter Tech Committee, or is it Winter CG?
I think they changed. So the GitHub org is Winter CG.
Okay.
But if you click on it, it says Winter TC, Technical Committee. So I think they had a rename. And so I think it's Winter TC according to the Winter CG GitHub org.
There must be an explanation for why it's called Winter, but it's not very descriptive, like on the face of it. But essentially, this group is a bunch of the people that are working on these runtimes coming together and saying, we got to make sense of this chaos. We need to create a unified standard for these APIs on the back end so that we can get consistency across deployments and these runtimes so that there's less chaos to manage. And it reminds me of what Microsoft had to do with .NET, because they had released .NET Framework for so many years, and then they rewrite it to port it to .NET Core, and now they've rewritten the entire stack, but they still need to support the older framework version, so they introduced .NET Standard, which is just a spec for here are the APIs that are supported in each version. And you could just target the standard, and you could say, I want to target .NET Standard 2.1. I can guarantee that it's going to be compatible with these versions of each runtime or these versions of each .NET framework across like mobile, desktop, and web and stuff like that. So I think we're seeing the same deal happening with JavaScript runtimes.
Yeah, and it's still early days for the Winter TC, but the things that they're talking about right now are things that are really important for most apps, and they're talking about a minimum common API that would be implemented by web interoperable runtimes. They're talking about sockets API, a CLI API, fetch, and crypto. These are all things that are shared by all of these and doesn't force like Deno to, not innovate or Bun to not innovate.
Right.
It's like, okay, this is the subset that everyone expects to have. And let's maybe agree to a minimum subset.
Yes. So I think another thing that's interesting here is we've talked about these different tools that all work around TSC. And none of them do type checking, but they all do some form of type stripping, right? Where it's a little bit less complicated, where they just replace type annotations with spaces to preserve source maps and stuff like that. And that's just to be able to get it into JavaScript. I think a good question someone might have, and sometimes I wonder the same thing, why doesn't Microsoft just make this easier on us all and either do something with TSC, either they rewrite a portion of it so that the type stripping at least is faster, or I don't know, what could Microsoft do? Should they do anything to make our lives a little bit easier?
I think there's like a philosophical stance here. Like there is a desirable property in the way that TypeScript is written right now as a bootstrapping compiler.
Yeah.
And being expressive in its own language. You lose that if you write the compiler in another language. So I think there's that. There's also no one else is going to try and implement a type checker because it is a monumental task and TypeScript moves too fast. So it would be a moving target. In fact, I think most efforts to write a type checker that is compatible with TypeScript have failed for precisely that reason. It's just a moving target. So that's why I think a lot of folks are targeting type stripping, which is a much easier problem to tackle. And then OXC doing this type declaration thing, which I think is, again, a smaller problem space than type checking. I think that's precisely the reason why we're not seeing TSC be written in Rust, and also why we're seeing this erasable types thing show up. Now, if I were to speculate, if you wanted to do this and still preserve, hey, Microsoft, listen, and I hope your ears are open. If you want to preserve the purity of having TSC be written in TypeScript, what if you did that, but you were able to transpile TypeScript into something else that is equivalent and faster? I don't know, like C or something. I don't know, Zig, Rust, something that is equally expressive as TypeScript.
Sure.
Or more. Then you can keep the purity and then also have a lightning fast.
Yeah. And
then you don't have to play catch up.
Yeah, I think I cannot comment too much on the technical feasibility of any of that. That's for much smarter people than me. But I have heard arguments of they may not need to do much like on their end, because for type checking, we've just gotten so used to now just having the language server in the IDE doing the type checks for us. So that's where we get the benefit of type checking, is when we're typing stuff in, right? There's less of a reason to run the type check separately as like a separate process, where you may want to just do it on CI/CD, and it's okay if it takes a few minutes longer or something like that. Because as developers, what we care about is the fast feedback loop locally as we're developing, right? And so these tools are taking care of that. And then if we can get the bonus of not having to run TSC to create type declarations, then that for sure helps us. Because if you're in a monorepo setup and you're referencing local packages, you want those types to be updated.
I think we can jump to like maybe the key takeaways here.
Yeah, for sure. What do I do? As a TypeScript developer, with what I'm working on, how does this all affect me?
Yeah, and I think my advice is always going to be use what makes you happy and productive. Don't use something because someone told you to.
Yeah.
If you're using Node and you're happy with it, don't change. And honestly, it's not worth it to go and rewrite everything in a different stack, different runtime, especially if you're not making a new feature. Like rewriting it for the sake of rewriting it is not a good reason to do something. Maybe you are looking at some new projects and you can tiptoe into a different thing. Like a bun might be one to tiptoe into because its stated mission is to be drop-in replacement. So you can maybe start there and see what happens. And you could learn how to run and operationalize bun in a production application. If you're doing something totally greenfield and you're willing to like crack out into a new project, I think Deno is where I'm like landing personally. I think Deno's got a lot of the like DX and paper cuts solved for me that are like associated with Node work, type projects.
But at the same time, like if you want to adopt Deno, you just have to understand that there's going to be a learning curve to it because it is not necessarily a drop-in replacement. And in 2.1 and the 2.0 release branches and stuff, they've made that a lot easier.
Yeah.
Where there is compatibility with Node, a lot of the Node stuff. But there's still going to be cases where you got to relearn stuff.
That's right. And I think folks are in a competition. So I think saying one is more performant than the other is not going to be a useful metric because they're going to trade blows. They're going to go back and forth and also looking at these performance graphs, a lot of them are micro benchmarks and not actually production workloads. Your app might perform better on one runtime than another. And I think it's down to measuring because the devil's in the details, and real production apps are a lot more complicated than these benchmarks are and are ever going to be. So I think anytime you see a performance benchmark, you need to be very skeptical, no matter who's giving it. And it's a dark art to make good performance benchmarks. And I think the best thing you can do is measure your own app and say, okay, is this good enough? Yes, no. And to do experiments and have observability on that performance of how your things are running in production. It's difficult or nigh impossible to know a priori if Bun, Deno, Node are going to be faster for you without actually just trying it.
Yes. Yeah, for sure. And I would second that of building POCs and prototypes to test out your assumptions on those. Because like even the blog post that we mentioned at the beginning where HTTP2 support is missing from Bun, and you would not have known that very easily. Maybe it's in the docs. Perhaps it is in the docs, but you probably didn't read that in the docs and you wouldn't find it out until you actually tried to use fetch on an HTTP2 API and it blew up. It's impossible for us, and we don't take a stance really on you should be doing this, you should be using Deno, you should be using Bun. It's totally dependent on your project.
Yeah, I like Deno because of the DX. And if anyone who's known me or talked to me or seen any of my talks knows that's like the most important thing for me. Doesn't matter if it's fast or slow. It does. At a certain point, it does. But a DX is the hill I'll die on because if it's easy for you to develop, it's easy for you to deploy. And things that are hard to develop locally, I find to be less useful tools.
Should we move on to our Secrets of the Handbook segment? You've got something cooked up for us.
Yeah, this is a pretty slick one. And I think it was a sleeper when it came out. But did you know, since TypeScript 4.0, you could name elements in your tuples?
I did not.
So in the past, you do colon, square bracket, number, and square bracket. And you'd be like, okay, what are those numbers? And you were left to comments as JS.doc comment as your only recourse for knowing what those were supposed to be. But you can now add a label colon to the front of your type. I believe it's to the front. I probably should double check that. And you get useful names on those tuples. So say you had number, that might be first colon number, second colon number in square brackets. Or it could be XY, or it could be lat long. It could be any kind of type, or any kind of thing you need to describe it. So it was a sleeper, super useful. Also, if I remember right, I think the language server also will help you out if you're going to do destructuring, and it'll pre-name your destructured variables with whatever label you gave them. I feel like I remember that being the case. Maybe that's not the case, but I feel like that is the case.
That's cool. And I literally have not heard of that until you actually mentioned it. So it definitely was a secret to me. So also just to help the listener in case they are not familiar with what a tuple is, because there was a time as a programmer where I did not know what a tuple was. Could you just explain quickly what a tuple is?
Yeah, it's just a fancy pants word for a group of a fixed group of things. It's like a list. And arguably returning a tuple is usually a smell, but it's also super useful for data that is compact like that, like XY or lat long, where you only ever represent them as a list of two things or a list of three things. And that's all that a tuple really is. a discrete list of things. And they're very common in other like error return languages. So like for Go, for example, always returns an error, like error value tuple is how they do things.
Okay.
They return an error and a value as a list of things. Don't quote me on Go because I don't program in Go anymore. That's one way to think of tuples. It's just a discrete list of things.
Cool.
And it's a fancy word.
So if I wasn't going to use a tuple in the example of a coordinate system, I'd have an object with X, Y as properties that would be numbers. But if I return that as a tuple, it's just an array with two items. X is the first value, Y as the second value. And in TypeScript, before this named tuples were available, I would have no idea what that array was, except for it is an array with two numbers. But now I can add a label that says the first number has a label of X and the second number has a label of Y. That's not what the variable names are. You still have to destructure it as like the two values. And then you could give your names to what those variable destructuring values are. But it makes the types more expressive.
You got it. Nailed it.
Sweet. There's a couple cool things I just wanted to mention really quick because someone had asked on Blue Sky, hey, does anyone know what version of Node supports blah, blah, blah syntax? And I replied and said, hey, I've used this website before. It's called node.green. That's the URL. And it is just a big, huge table of different ECMAScript features and what versions of Node they're supported in. And just want to say that it's up to date, right? Yes, it's up to date with the nightly, even Node 24. So it's been maintained for a long time. I used to use it day to day when I was working. So definitely check that out if you ever have those types of questions for what APIs are supported in Node.
Yeah, and the other cool thing that I can't live without in VSCode is pretty TypeScript errors. It's a plugin, and it uses some smarts to parse TypeScript errors and give you a little help in like reading them with some like nice formatting, and it understands what certain errors are. And it's been featured on several like programmer YouTube channels, but it's a sleeper as well if you don't subscribe to like those YouTubers. But I definitely recommend Pretty TypeScript Errors as a big help for deciphering some of those giant errors.
Yep. Again, I had no idea until you mentioned it. So I did not know about this, but this is super cool.
Awesome. I think that's a show. And dang, we covered a lot. And we probably missed a few things too, because it's just a huge space and there's like a ton of new runtimes entering the space. So this is definitely not an exhaustive list, I don't think.
No, it's a learning opportunity for us, and hopefully you got value out of it, dear listener. But this episode, I think, is long enough. So we will say bye-bye.
Bye-bye.
Hi, everyone. This is Kamran. I just wanted to thank you for listening to the show, and we hope you enjoyed the episode. If you want to see the show notes, you can check your podcast player or go to typescript.fm, where you'll see a list of all the episodes. If you enjoyed the show, tell your friends, and please rate it on Apple Podcasts or Spotify, because that's how the show grows and gets discovered by more people. If you want to suggest news or a project that should be covered, or just want to say hi, email us at feedback@typescript.fm. If you want to follow us on social, we're both active on Blue Sky. I'm at kamranicus.com and Erik is at erikonerheim.com. You can also follow the show directly at typescript.fm.